In this section, we will learn service management with systemd by creating a service unit from scratch. We will then look at the tools used by systemd, specifically systemctl and journalctl. We will close this section with a hands-on lab exercise. Bob provides his list of requirements to Dave. He has a shell script called project-mercury.sh located at /user/bin. This has to be started in the background as a service and enabled to start during the boot. This script starts his Python Django application on the laptop. The application, however, depends on the Postgres database. The Postgres service should be up and running before the Python application can be started successfully. A service account by the name of project_mercury has already been created in the system. The service should make use of this user to run. If the application fails for any reason, it should restart automatically. If it fails again, Bob wants to ensure that the system tries to bring it up after waiting for 10 seconds. Bob should, however, be able to shut down the service himself. In this case, it should not restart automatically. The application events, including start, stop, and failures, should be logged in the system somewhere. This is important so that the reason for the failure can be investigated later. Bob uses the graphical target as a default on his laptop. The service should start with all these conditions in the graphical target. Dave looks at his list and says, "That's a lot of requirements. To make it easier, let's take one condition at a time and build on it." He continues with the explanation. To run this command in the background, we have to define it as a service. For this, we will create a service unit file. This unit file, let's call it project-mercury.service, needs to be created under /etc/systemd/system directory. Let's start with the command that you need to run in the background, which in this case is /usr/bin/project-mercury.sh. The most basic service unit can be built with just this information. The body of this service unit looks like this. We have a section called Service, which is enclosed between square brackets. And underneath, we have a derivative called execstart, which is used to run a command or an application. Since this is a bash script, we will specify the command as /bin/bash, followed by the absolute path to the script as the argument. That's it. A service definition can be created with just these 2 lines. To run this service in the background, issue the command systemctl start project-mercury.service. You would have to use sudo at this time, as the service is set to run as the root user by default. Your script should now be running in the background. To check this, you can issue the command systemctl status project-mercury.service. It should be in a running state. That's one of the requirements completed. But we are not done. Sure, this service runs in the background, but it cannot be enabled to start automatically during boot yet. Let's fix that by updating the service unit. But first, let's stop the service using systemctl stop project-mercury.service command. To allow this service to be enabled during boot, add another section called install. Just as we did with the service section, the keyword install should be enclosed between square brackets. Under this, use the wanted by directive, whose value should be the systemd target or run level you want to enable it for. Since you are running in graphical mode, we will set the value to graphical.target. One more requirement is complete. So let's add the service account to be used to start the service instead of root, which is the default. To do this, add another directive under the service section. The directive name is user, and we can assign the value of project_mercury to it. We can now build on this and add a couple more directives based on the requirements. Use the restart derivative, which defines how and when to restart the service. Set the value of this derivative to on failure. This will ensure that the system attempts to restart the service should it fail for some reason. And since we have set a restart derivative, we can use the restart sec derivative to set the time in seconds to wait before the system attempts to restart it. We will set this to 10. Finally, with systemd, the service events are automatically logged, so this requirement is automatically taken care of without any additional configuration. Now we can start the service again. But before we do that, there is an opportunity to make it even better. Since the Python Django application depends on the Postgres service, we can define a dependency that makes sure that our new service is started only after the Postgres database is ready. To do this, we need to add another section to the service file called unit. Under this section, use the after derivative and set its value to PostgreSQL.service. Within this section, you can also add the description of the service and any documentation you may have about it. These are not mandatory, but considered to be a good practice. Now we are ready to start this service again. For the system to detect the changes we made in the file, run the systemctl daemon reload command. To summarize, all your requirements can be mapped to specific sections of the service file by making use of derivatives, which would look like this. The dependency on the Postgres database goes to the unit section. The requirement specifying the service to start in graphical target goes to the install section. Everything else goes to the service section. Bob makes a note of the steps with the intention of replicating it in the dev server later.